we need to find the solution to the given initial value problem. So we're going to do both of these, and you'll see how simple it is. So finding the solution to the given initial value problem, all we need to do is put this, our y prime, in a dy dx. We want it to be separable. So once our y prime is dy dx, we are going to kind of multiply everything around and get it into a form where it is separable. So it's going to look something like this. Y negative 2 dy is equal to 1 minus 2x dx. And that's just multiplying everything, and this one, we're just flipping it over. That's why the exponent is negative. So now we need to integrate. We need to get it to where we can plug our 0 for x and negative 1/6 for y inside. We're going to find our c and form a solution for this. So in doing this, we know that the left side is going to give us a negative y to the negative 1. And this is going to be equal to a x minus x squared plus c. So it's going to look like this. It's pretty simple. And then from here, all we want to do is plug our values in, right? So for something like this, if we plug in a negative 1/6 in for our y, with this negative 1 on top, we're going to be flipping it over. So this is going to be like a 6, and this is going to be equal to, our x's are zeros, so c is just 6. So plugging this in and rewriting this out, we are going to get a, and I'll rewrite this out a little bit slower just so we don't make a mistake here. We have negative, it's going to be a 1 over y is equal to, and then we're going to have our x minus x squared plus 6. Now we can flip everything over and multiply everything by negative 1. So y is going to be equal to, we have 1 over x squared minus x minus 6. So that's going to be the answer for this one. Now let's look at this next one where we want to solve for our dt. And this one's going to be a little bit different because we have this e raised to t plus y. Well, the way we can break this apart is this is equivalent to et times ey. It's the equivalent. So now you can see how it might be a little bit simpler multiplying everything around. We're going to have a 1 over ey times our dy, and we're going to set this equal to an et times our dt. Now we're going to integrate both sides, and after we integrate, this one right here, it's just like on the left, it's equivalent to e raised to a negative y. So this is going to be a negative e raised to the negative y. And this is going to be equal to an et plus c. That is it. Now from here, we can plug in our values from here actually. So you can either solve it all the way like we did on 9, or we can just plug in the values from here. We know our y is 0, so this is going to be 0, and our t is 0, so this is going to be 0. So from here, we're going to write this out, and remember, we'll come back to this when we want to solve eventually. But we have c plus e raised to 0 is just going to be 1. This is going to be equal to e raised to a negative 0 is still 1, but we have this negative out front, so it's negative 1. So we have negative 2 is equal to c. So c is equal to negative 2. Now we just need to plug this in. So let us, since we have y on the left hand side right here, let's multiply everything by a negative. I want to get rid of that negative. We'll do e raised to a negative y is equal to, we're going to have a, this should be a negative e raised to t, and then if we multiply the negative over, it'll be minus c, but we have c is equal to negative 2, so we can have a plus 2 like this. And then from here, to get rid of this e, we want to multiply everything by ln. So we'll have a negative y is equal to ln absolute values negative e t plus 2. And then we just multiply the negative 1 over. So y is equal to negative ln negative e t plus 2. And that's how we would go about solving for the given initial value problem. That's what you're going to want to do to get the correct answer for it. And that's how we would solve these.